So we've got our cylinder, radius r and height h, and we've got equations for both the volume and the area. And what we want to do is, volume and area in terms of radius and height. So what we want to do now is let one of the things change. So what I want to do is just say what happens if the radius increases a little bit. So we're going to let the radius change and go to radius plus dr. Okay, so dr is an increment in r, a small amount of r. So the little d here is changing, or usually a small changing. What happens to the volume? Okay, so the volume will now be equal to pi, and it's r squared h, but r is now going to be replaced with r plus dr squared times h. And if I expand that, break it out, I get pi r squared plus 2r dr plus dr squared times h. And if I expand that out, I get pi r squared h, which you'll notice is the same as we started with, plus pi 2rh from this bit, plus what we call second order. Okay, so the dr squared, if dr is very small, so like if dr was 1/1000th, then dr squared would be 1/1,000,000th. So as you start to square something small, it gets even less and less significant. So effectively, we ignore the second order terms, and we say that what's happened here is that the oops, I've missed out a dr here. No, that was 2 pi r dr. Okay, so we say that the volume has increased by this much, because this is the same as the original volume. We're going to ignore the second order, so this is the increase. So the volume has increased by pi 2rh dr. Okay, so that's what happens to the volume as the radius changes. It's going to depend on the amount of h, but it's dr as r increases a little bit. This is how much the volume increases by.